video about periodic trends, electronegativity. Okay, before we talk about electronegativity, something you need to remember is what a covalent bond is. So a covalent bond occurs between nonmetals. So when a nonmetal is bonded to a nonmetal, like oxygen bonded to oxygen, or nitrogen bonded to oxygen, or fluorine bonded to cesium. In this type of a bond, hopefully remember that electrons are shared. Remember, when elements come together and bond, or when atoms come together and bond, they need to do something with their electrons. Either they're sharing them, or other things can occur, such as completely transferring them. Okay? Completely transferring electrons is the other type of bond, which is ionic. That will come up a little later. So also, if you remember, when we share electrons, you could share them evenly or unevenly. So if we remember, we have some atoms, right? So if this is an atom bonded to another atom, some atoms that share those electrons evenly. So we'll kind of put them in the middle. That's even sharing. And then some don't share as evenly. So maybe we have this one hogs the electrons more. That's uneven sharing. Okay? So that's something you should remember. Why? Well, because our topic today, electronegativity, talks a little bit about that. So let's look at what electronegativity means. It's just a word that means it's the ability of an atom when it's bonded, meaning in a molecule, right? Bonded, to attract shared electrons to itself. So if you remember in this picture, this is a molecule, right? Two or more atoms bonded together. This is a molecule. So it's the ability of an atom in a molecule to attract shared electrons to itself. So we're going to be looking at each atom separately and see what its ability is. Like, for example, if I look at this one, I'd say, oh, this one has a high ability to attract electrons to itself because I see them next to it. This one has a low ability. This atom has the same ability as this atom. This ability we measure and we call electronegativity. Okay? Now, something else we had talked about that you should remember is that when we talk about uneven sharing of electrons, these molecules are also called polar molecules. Okay? We're going to focus on the uneven sharing part. The uneven sharing of electron is when one atom hogs the electrons to itself. This concept is described in electronegativity. Okay? All right. So, in electronegativity, you are given values. Every element has its own electronegativity value. So maybe we can write that down. Every atom has its own electronegativity, I like to abbreviate it like that, value, which you will be given in a chart. So you will receive a chart. Okay? So if I was to take a look at some of these examples, what do I do to actually figure out electronegativity? Well, here's hydrogen bonded to a hydrogen. It's a molecule. I look up hydrogen's value on the chart. And when I do that, I notice its electronegativity is 2.1. And so is this hydrogen's 2.1. When we want to see what the overall electronegativity value is, we subtract them. We take the difference. So 2.1 minus 2.1 is 0. That's my electronegativity value. So if you notice, no units, no units, no units. Electronegativities are just values that don't have any units. So nitrogen bonded to oxygen. Here we go, nitrogen bonded to oxygen. I look up nitrogens on my electronegativity chart, which will be given to you, and I find it to be 3.0, and oxygen is a slightly higher 3.5. What does this mean? This means that oxygen hogs electrons more to itself because it has a higher value than nitrogen. Okay? We can calculate the difference, which is 0.5. Keep it positive, so make sure you subtract big from small. So these two electronegativity differences, or these two values, are the same because it's the same element. But over here, we learned something new. Nitrogen has a low electronegativity compared to oxygen. So oxygen's going to hog those electrons. So what would that look like? Well, if this is nitrogen, right, and this is the oxygen, then we would see those electrons closer to oxygen because it has a higher electronegativity value. It has a greater ability to attract electrons to itself. Okay, so let's take a look at another example. In this example, I have CCl4. Now, even though I have 4 chlorines, we're just looking at the atom's ability to attract it to itself, so I don't have to worry about that 4. I look up carbon and chlorine. Carbon's 2.5, and chlorine, not 4 times chlorine, just chlorine, is 3.0. Clearly, I see from these two numbers who's going to hog the electrons more. This electronegativity of chlorine is higher, so it's going to hog electrons more to itself. So how do I figure out the difference? I subtract them from each other and I get 0.5. Now, from this value, I can find something called the bond type. I can actually figure out what is the name of the bond that exists when carbon bonds to these 4 chlorines. What is the name of these bonds? And the way we do that is pretty simple. We use this chart. So if you look here, this chart ranges from 0 to 3.3. If when I do my subtraction, it falls in this range, 0 to 0.4, it's nonpolar covalent. When I go from 0.4 to 1.7, the bond type is called polar covalent. And if the difference lies between 1.7 and 3.3, the bond type is called ionic. What's the difference between these types of bonds? A nonpolar covalent is, again, covalent is between nonmetals, but nonpolar means equal sharing of electrons. Polar covalent means unequal, as we heard earlier. And ionic, as we know, is a complete transfer of electrons. They're not sharing at all. They're just saying, here, take my electrons. Okay? So, if we bring back our example that we did a second ago, and we calculate the difference and we get this number, we plug it into the chart. 0.4 is here, so 0.5 is right behind it. So polar covalent is the bond type. Polar covalent. Uneven sharing. So a nice way to draw these out and to look at these bond types are seen here. Here's 2 atoms. And notice these 2 atoms, here's their nucleus, are sharing these electrons evenly. This is called nonpolar covalent. Here's 2 atoms. Notice they are not sharing them evenly. This atom has hogged the electrons closer to itself. This is called polar covalent. And in this example, this atom completely gave up, transferred its electrons to the other one. A complete transfer, no sharing, that's called ionic. Different types of bonds. All right, but what about the trend? Let's talk about the electronegativity's trend. Okay, in order to do that, let's talk about what it means when we say electronegativity decreases versus electronegativity increases, because that's the way we're going to discuss trend. Okay, so my trend is going to be looked at across my periodic table and down my group. Okay, and I'm going to either talk about that trend increasing or decreasing. When I say my electronegativity decreases, that means I have low ability to attract an electron to myself. When I say my electronegativity increases, it means I have a high ability to attract an electron to itself. Okay, well, what is the thing in an atom that attracts an electron? Hopefully you said the protons, the positive protons. So let's think about that as we look at this. So here's my electronegativity trend. It's the ability to attract an electron to itself in a bond, meaning gain electrons. So we're going to look at this trend going down the periodic table and also going across, going down a group or across a period. So as I go down a group, electronegativity decreases, meaning I don't have that great of an ability to attract electrons. Why? Let's first start with that. Why? Well, hopefully you remember that as you go down a group, you have more and more energy levels, right? In this atom, I have 1 energy level. This one, I have 2 energy levels. This one, I have 3 energy levels, 4, and then 5, 6, 7. And so if my electron is sitting here on my outermost energy level, and I'm trying to attract that electron, remember the positive nucleus attracts it. Well, in this example, this electron is going to be very attracted to this proton because it's so close to it. In this example, the electron is going to be not as attracted. And in this one,
an electron's going to come and really not feel much of an attraction here, and even less attraction. So as you notice, as I go down a group, the ability of this atom to attract an electron decreases because I've got all these energy levels blocking that positive charge. So more energy levels as you go down a group means more shielding of the positive nuclear charge. So the nucleus can't attract to an electron to itself that well. Okay? How about the other trend? How about when I go across the period? Where, as we saw a second ago, as you go across a period, electronegativity increases. I have a greater ability to attract electrons to myself. Well, why? Well, what happens when I go across a period? Well, the proton number increases, right? I go from 1 proton to 2 to 3 to 4 to 5 in this example, but across any period on the periodic table, my proton number increases because my proton number is the same thing as my atomic number. So I have not many protons here, a little bit more, a lot more, a ton of protons. Protons attract electrons. So if this atom is trying to attract an electron with 1 proton, it's kind of weak. A little bit better, this one has a much greater positive charge, and so forth. This one can attract an electron the most to itself because it has more positive charge, which pulls it in more. So because, as you go across, because the number of protons increases, then therefore it can better attract electrons to itself in the bond, and so electronegativity increases, because electronegativity is the ability to attract electrons to yourself in a bond. That's the end.